Right. So in this experiment, we'll be looking at one of the uh, basic organic chemistry experiments uh, that we commonly use them for separation of substances, and the common name for for this technique is chromatography. So chromatography is a method which we use to separate compounds based on the affinity of the compounds to the stationary phase and a mobile phase. So when I say the affinity of the compounds or the solid sample to the stationary phase and mobile phase, it has to do with the polarity of that compound with respect to the stationary phase or the mobile phase. So consider the two samples A and B in a mixture. So A and B are mixture of compounds, which each of them are independent compounds, and when we dissolve them, they will be in an equilibrium. So if we spot or if we add these two compounds and the mixture of these two compounds into a chromatography, any chromatography technique, if it is column chromatography we are using, we have to place them at the top mouth of the column, or if we are using the TLC, thin layer chromatography, which we will be using in this experiment, we will spot them at the bottom of the plate, and then you will see them moving depending on the affinity of these compounds towards the stationary phase, or the solid stationary phase, or the liquid mobile phase. If we take a look at the diagram, A and B were in a mixture and at equilibrium when they were put in the stationary phase. However, once we connect the plate with the mobile phase will start to move up in the TLC or down in the column chromatography, and then the compounds will start to separate. So from the picture we can tell that A is going faster than B because A has similar polarity or near polarity towards the mobile phase than the stationary phase. So we have actually three techniques of chromatography. The first one is an old technique. Of course, it's used nowadays, but it's not effective compared to the thin layer chromatography and column chromatography, but it is paper chromatography, where water is acting as a stationary phase and any solvent or mixture of solvents will be a mobile phase. So it's not like a usual paper. The paper chromatography has a special kind of paper used for this kind of technique. And the second technique is thin layer chromatography, which we'll be discussing in detail in this experiment. And the third technique is column chromatography, where the solid phase is packed in a column in a glass tubing, and the sample will be put at the top of this glass tubing, and the separation will happen as the result of the solvent movement down the column, which we call it due to gravity action. Whereas here, the solid phase in thin layer chromatography is mostly a powder with it's either a silica or alumina. To make this powder planar, we have to support them with other inert materials like glass, plastic, and aluminum foil. So these powders will cover the entire aluminum foil or plastic sheet, and so that the separation will be easy. So these substances are polar compounds, which we use them as stationary phase, whereas our mobile phase could be a given solvent or mixture of any organic solvents depending on the nature of the compound or nature of the mixture we are trying to separate. And basically, polar solvents tend to have a rapid movement of substances, which is clearly due to the strong attraction of the polar solid phase toward this the polar solid phase towards polar substances, and so which means the less polar solvents will be excluded faster in the process. So this is an example of so the picture is an example of a TLC experiment done in some other labs. So the TLC chromatography, in TLC we have our own chamber to run the experiment. However, because the chambers are big and they might not be all available also in many labs, we can substitute them with beakers. The only thing we need is a beaker but with a lid. So you can see the beaker and looks like a base of a petri dish, which is used here to cover the experiment, and the plate, the white plate you see lying at the top of the beaker is the actual TLC plate. So this is a thin layer chromatography experiment which is already done. So if you see at the bottom tip, you can see a silvery shiny part that shows us that the supporting material is aluminum foil. So the white powder is the silica gel, which serves as our solid stationary phase. And this solid phase is actually coated in the factory. We don't do that in the laboratory, and it's already prepared. What we need is to cut the thin layer, the plate to our desired height and to our desired length, depending on the number of samples we have. This is another good example of thin layer chromatography experiment, where in this experiment they try to separate a mixture of 3 similar compounds, the ortho, para, meta, nitroaniline. So this is even where we appreciate the application of thin layer chromatography. If you see the right side, the first spot to the right side is an unknown compound, which literally contains all of these three compounds. The three spots to the left are pure compounds. So when this TLC ran, you see that the yellow spots of these unknown come parallel to the yellow spots of each individual pure compounds, which makes it easy to tell which compound is which. The first, by looking at the picture, the first spot for the para, which is the bold spot you see, is also seen a little bit faded spot, but that it's there, you can see in the TLC, and that simply tells us that's a para. That's a para. If you calculate the RF of this para and RF of this unknown compound, you will find the same or very near values or retention values, and you can tell that the compound is para nitroaniline. And so once we undergo our TLC for colored compounds, we can simply identify them by just using our naked eye, but there are also some other non-colorless compounds where we need to spray an iodine to make the spots visible, or most commonly you can use UV light. So, and if you put your plate under UV light, the silica has a fluorescence dye. It will look as green, whereas the spots will appear as black spots as a result of their UV light absorption. And in that way you can separate, you can identify the spots and mark them with your pencil very easily. Here I need you to know that when we handle the thin layer chromatography after the experiment or before the experiment, we have to hold it by the edges, not by the paper. Otherwise the silica is a pure homogeneous compound, and if you have some chemicals in your glove or in your finger, they will contaminate it and you will lose your experiment. So this is all the step for the experiment. We will have a desired size thin layer chromatography, which also depends on the size of the chamber we're using. And once we got the desired size of the plate, we have to mark a bottom line with a pencil right 1 centimeter to 1.5 centimeter above the bottom edge of the plate. And then second step is to mark spots with a pencil. You do the lining with a pencil as well as the spotting with a pencil, and then you use your capillary tube to spot the samples. Once you spot the samples, you enter the plate into the chamber containing the solvents. You close the chamber and let the separation happen. Once the solvent goes above 3/4 of the length of the plate, you can remove, mark your solvent front with a pencil and dry your thin layer chromatography. So After the experiments, we need to calculate RF values. Why? Because this is the simplest way to identify the compounds. Because RF values are numerical representations of the polarity of the compound, the sample compound, with respect to the stationary phase and to the mobile phase. And for this graphical representation of the RF, the thin layer after the experiment, you can see that the spot with the blue color is the spot of the compound, whereas the line with the I don't know the color, but with a kind of greenish color leveled by 4 is the solvent front. So the RF value of sample 2 will be the distance from the number 1, which is the starting line, to number 2, the spot, divided by the distance from number 1, the starting line, to the front line. Spotting should not be done just using a needle or using tip of any material. If you do that, you'll have incorrect separation of the samples. You may have broad spots, you may have even spots that go round, not straight. So the best way to do is using a capillary tube. For thin layer chromatography, we use capillary tubes with both sides with opening in both sides. But because the opening is very wide, we have to make certain arrangements to have a narrow opening. To do this, you need a Bunsen burner and a capillary tube. You have to hold the capillary tube at the middle near to the flame, and after some time you will see the capillary tube will soften and then release from the flame, pull from both sides, and you will see the capillary tube will stretch like a plastic, and then let it dry. It will dry in a moment, in an instant, and then break it in the middle, and you'll use this narrow opening to spot your samples. So like we said in the beginning, the solvent we use for thin layer chromatography could be a single solvent or a mixture of solvent. It all depends on the material we're using. However, a good solvent for the TLC is a solvent that gives us good separation of these compounds. The general concept on organic compounds is that so you can see that polarity goes as we go from alkanes to carboxylic acids, and so in the same sense, if we have a compound which is in the alkane group, so that's to mean it's non-polar compound. If we have a compound like benzoic acid, which will be polar compound, and because we use because the key concept here is that our stationary phases are polar compounds. So if you use if they are polar compounds, and if you use polar compounds, then you will see the compounds will remain at the bottom of the thin layer chromatographic plate, whereas the non-polar compounds will go along with the mobile phase, and we shall see them at the top of the plate. In this experiment, we'll be using a mixture of analgesic tablets. Well, these tablets are painkiller tablets, which we use them as a medical treatment. And you guys may know the ibuprofen, aspirin, naproxen, or acetaminophen, aminophene, which are commercially available in the pharmaceutical stores. And because these have different polarity, we'll be trying to separate them using different mixture of solvents. And so how is the mixture going to be separated? So because you see these compounds have different polarity, they will have different interaction with the stationary phase and with the mobile phase. Normally, like we said in the classes of organic compounds, the more polar compound will be stacked at the bottom because it is close polarity to the stationary phase, whereas the non-polar compound will go along with the solvent, and you will see at the top of the stationary phase. And with respect to so from this experiment, you can tell that the compounds that are polar should be the compounds having polar functional groups. So if you go back and see the slides, those compounds having hydrogen bonds like OH and NH bonds are chemically polar, and they will have higher affinity to stationary phases. So during the experiment, the first thing to do is just preparing the TLC. For sure, a TLC plate will be prepared in the lab at a desired size. Your first task is simply to line the plate with a pencil from 1 to 1.5 centimeters from the bottom each, and then you have to mark the line at different points still with the pencil. When you mark different dots in the line, it depends on the amount of samples you have. If you have 4 samples, you have to divide the line in 4 equal portions. If you have 3, and then you do the same. And so we mark the line with our pencil, and then each dots of the pencil will be used for each sample. Okay, for each sample to be spotted. So in this experiment, we'll be using 3 unknowns, or when you're interested to undergo 3 unknowns, we will be using 3 different mixtures. So for the first unknown, we'll be using glacial acetic acid and 1,2 dichloroethane in 1:12 ratio. For the second unknown, we will be using 4 mixture of solvents in 5:1:2 ratio, and the solvents will be dichromethane, acetone, an analytical grade ethanol, and hexanes. And for the third unknown, we'll be using acetic acid, ethyl acetate and glacial acetic acid in 25:1. So we prepare our mobile phase and we spot our samples, and then the next step is simply to gently put the thin layer plate into the solvent. And here make sure that the solvent level does not touch the line, otherwise the samples will drip down to the solvent and we will not have any separation. And then make sure and then the next step for sure is to close the chamber with appropriate lid. So how do we analyze this? How do we analyze the thin layer plates? So after the experiment, comparison or identifying of sample, in addition to the visual identification, is we calculate RF values. RF values, okay, we calculate RF value. How do we calculate RF value? The same way we discussed it in the before slides. So key concepts during the experiment. It is, so you do not have to touch the face of the plates, as you can easily contaminate the plates. And when you make the marks for the different samples, and when you draw the sample, the line, you have to use pencil. And again, once the experiment is started, you have to look it closely at how the solvent is going. Some solvents going fast and some solvents going slow, but in either way you have to remove the plate from the solvent, from the chamber, once it reaches above 75% the length of the plate. And also you have to make sure that the bottom line does not touch the solvent from the beginning. Another thing is the environment of the chamber should be saturated. This will be done by covering the chamber with an appropriate lid. If you are using a beaker, you have to find a petri dish or watering glass or any flat glass to cover the beaker. And again, here sometimes it appears that the thin layer plates are longer than the actual beaker we're using, and in that case you may need to cut the plate so that you can cover the chamber nicely. Well, safety matters regarding this experiment. If you remember the solvents we use, dichloromethane, ethyl acetate, and all the 1,2 dichloroethane, all these solvents are flammable and they have health threats, and they shall be all handled in a fume hood. When you do the experiment also, you have to hold the beakers or the solvents away from your mouth so that you can minimize the inhalation. Before you do the experiment, it is mandatory that you wear your safety gloves and goggles. In fact, if there are some chemical safety data sheets in the laboratory, it's good if you read them before the experiment starts, or if it is during the experiment, you can ask your TA for help regarding the characteristics of the chemical or the solvent you're using. And finally, at the end of the experiment, your thin layer chromatography plate should look like this. That's all for this experiment. And if you have any question, again, I will see them in the comments on the YouTube channel. Thank you.